Hi guys, welcome to my first vlog, my video blog about health and disease. My first video will be about cancer and exactly what is cancer and what makes a cell cancerous. So to start off with, we're going to be talking about what is a normal cell so that we know what's different between a normal cell and a cancerous cell. So a normal cell becomes a cancerous cell during a process called cell division. Usually what happens is one cell divides into two, but with cancer, the copy of the cells basically contains some sort of error. And that is essentially what makes a cancer cell a cancer cell. It has some sort of mistake in it. So how does normal cell division happen? With your normal cells, essentially what they do is they first check if the conditions are right for them to start dividing. So for one cell to become two. They look around to see if there's enough energy and nutrients. So they basically ask, do I have enough food? Because I'm literally going to be dividing myself up into pieces. So I need to make sure I have enough energy to do this. They check if there's enough growth factors in the environment. Basically what this is looking at what the other cells around them are doing. And those cells will send signals saying, well, we seem to be in great conditions right now, so let's divide while we can. And then the third thing that a normal cell will do is check if its DNA is damaged. If there's some sort of mistake in the DNA, the cell will not divide and it will go into a resting state where it will stop division completely. And the difference here with a cancer cell is it won't stop. It will keep on growing. So once a cell commits to moving on from that phase and actually starting to divide, this is a kind of irreversible process. It can't just go past step one and then decide, okay, we need to reverse gear this and go back because we've got some weird stuff happening in us. Can't do that. So it needs to have checkpoints to see, okay, I've passed step 1 and 2. Now, am I actually doing what I'm supposed to be doing? Do I look normal? Do I feel normal? So firstly, what the cell does is start to copy its DNA in a process called DNA synthesis. And it's quite literally the cell making 2 copies of its DNA and making 2 copies of itself. And putting it into a cell and seeing at that point, did I copy the DNA correctly and do I have enough DNA? And this is what happens at the G2 checkpoint. So it checks, well, is my DNA copied correctly? Do I have some sort of mistake in it? And then also, do I have the right cell size? Or is one cell much bigger than the other? In which case, it means that it didn't divide its nutrients accordingly. If there's a mistake at this checkpoint, specifically with the DNA replication part, a normal cell will recognize that there carries this mistake, similar to what happened at the G1 checkpoint. And essentially what will happen is it will stop dividing at that point and undergo something called programmed cell death, which is basically where the cell commits suicide. It sees it's carrying a mistake, it knows it shouldn't be passing this on to other cells, and so it kills the cells immediately. So it kind of sacrifices itself to save the rest of the cells around it. A cancer cell, however, doesn't go through this process. A cancer cell knows it carries a mistake and still divides anyway. It keeps on dividing and it evades these checkpoints which signal to the cell to actually kill itself. So it does not kill itself. It becomes essentially immortal because it doesn't self-correct and it keeps on growing with that mistake, giving rise to more and more cells carrying that mistake. Once a cell has passed the G2 checkpoint, there's another checkpoint called a metaphase checkpoint. And this one is a bit more complicated. Basically what happens here is you've already got the right copies of the DNA in the cells, but now the cell needs to make sure that the DNA is in the right place. So DNA doesn't just float around your cells randomly. It's in a very specific part of the cell, and it has to be, it's kind of like on a specific road in your cell if your cell is a city. Okay, so it's on a very specific road that's protected from bad weather and all sorts of bad things that can degrade that DNA. And this is what is checked for at that metaphase checkpoint. The cell basically sees, is my DNA in the right place? Is it being protected? And if it's not, it kind of slows this process down to bring the DNA to the right place in the cell before moving on. And then what happens is it goes back into a resting phase where it kind of calms itself down, says, okay, well, I've divided now, let me just grow a little bit. And it waits for other signaling cues from other cells to see should I divide again or not. Now, not all cells are dividing at the same time. Cells receive these cues at different times. So it's not like on a Monday all your cells start to divide. It happens kind of over time, all the time, with different cells. So the difference again between a cancer cell and a normal cell is just that a normal cell has the self-correcting mechanism where if it carries a mistake, it recognizes the mistake and is able to commit cell death or cell suicide to prevent passing this mistake on to future populations of cells. Whereas a cancer cell is kind of super selfish and doesn't really care about anyone else. He knows he's got this mistake and he's just going to carry on growing. And essentially what it does is make more and more cells, and eventually all these cells form something which we call a tumor.